Yes, welcome back. So I am back for the tutorial of chapter number 13 today. Yes, question number 1. What is a force? So you have to find out the force. That is required to pull. Keep in mind, you are not being asked to find the restoring force. This is the pulling force, okay? To pull a spring with a spring constant K 20 Newton per meter. So this is K. For a distance of 25 centimeter. So divide by 100, you will get in meter. Now we have the Hooke's law, which says force is equal to kx. K is given to you 20, x, so you would get 5 Newton force. Done. Second question. Calculate the elastic potential energy. Elastic potential energy you have to find out. In a spring, when the spring is stretched from 7 centimeter to 15 centimeter, from 7 to 15 centimeter. So x or delta x will be equal to 15 minus 7, 8 centimeter divided by 100. So you will be getting in meters. So this is the extension. All right. Okay. Now we know that elastic potential energy due to the spring is equal to half kx square. K is given to you, right? And you have to find out potential energy elastic. So we are going to calculate it now. 50. So you get in the unit of joule elastic potential energy 0.16. Done. Next. A 0.4 kg block with an initial velocity of 2 meters per second collides with a spring that has spring constant K is given to you, and calculate the maximum compression resulted from the collision. So x you have to find out the compression. Right. Sorry, I think I am missing this diagram. Okay. VI. Okay. You see, once this block is moving, in this direction with 2 meter per second, it collides the spring and it will compress it. So once it compresses it, it will be attached with this. So how much, X you have to find out. We have half mv square plus half kx square, which is the elastic potential energy. Even you can add potential energy gravitational mgy, but since this is the horizontal, not like this one, so we don't take that one 0, by the way, both sides, is equal to half m vi square plus half kx final. Right? Now, kinetic energy final, this is 0 because it will compress it, and this is 0 because initially there is distance between these two, it is not compressed or stretched. So you are left with vi square is equal to half kx final. Even you can keep without these, no problem. So you have half goes with half. You need to find out x, k take here, and then you can take the under root m v square by k under the root. So x will be v, what is okay, right, so x will be equal to m, how much? 0.040 v square, because this is square and under root, so it will come after that. So 2 over k 25. So x will be equal to 0.25. Okay, that's it. Next. Yes, Jose Current Mountain in Peru has the lowest gravitational acceleration. L is given to you at this location, and 62 vibrations in 1 minute and 40 seconds. 1 minute equal to 60 seconds, 60 plus 40, 100 seconds. So time period is equal to time over vibrations. This is time. Time is 100 vibrations. How many? 62. So time period you get in second 1.61. Okay. So you have to find out the time period. This is oscillation time. We just finished. Then you have to find out value of G. Value of G, we already did one example in the chapter. 4 pi square L over T square. 4 pi square L is 40 centimeter, mean 0.40 meter divided by 100. T square. So you can calculate. I don't have the calculator, but you can double check it. I think it's maybe 6.1. If there is something wrong, please do tell me. All right. Next.
The position of a vibrating object is given by, so the position function is given to you. Okay.
This one I can write it here. Divide by 100, it will be 0.1 meter. Okay. Cosine of 4 pi into t. Right. This is your given function, and the standard is x is equal to a cosine of omega t. This is the standard form of the position function for the waveform, and this is
The given to you in this example, and you have to find out
A, F, and T. Amplitude, frequency, and time period. You have to find out. Now we have to compare these two equations. One is given to you, one is the standard wave function for position. So x, nothing to do. A is equal to how much? 0.10 meter. Done. T, so omega is equal to 4 pi. We have,
the frequency and the time period.
Frequency is equal to,
omega is equal to 2 pi f, by the way.
omega is equal to 2 pi f, which is equal to 4 pi. Omega is equal to 2 pi f, okay? Right. So frequency will be equal to 2 hertz. And since time period is the reciprocal of the frequency, so 1 by 2, so 0.5 seconds. So time period, frequency, and amplitude done.
Next. Right. A motion is said to be simple harmonic motion when the net force is directly proportional to the
Displacement.
Next. The speed of an object attached to a spring undergoing simple harmonic motion is 0 when the spring's displacement equals amplitude. Right? When the spring's displacement equals the amplitude.
Amplitude. By the way, this is not displacement, this is the magnitude of the displacement, by the way.
Alright. And then you have the elastic potential energy for a spring that is at an equilibrium state. Okay, neither stretched nor compressed is 0. Right. Then you have the last but not the least,
the unit of the spring constant K is Newton per meter. The elastic potential energy of a spring is given by half kx square, and the unit of frequency is hertz.
Okay, that's it. Thank you very much and have a nice day.
End of this tutorial, chapter 13.